Hopefully this will be a quick video. Titrating a weak base with a strong acid to equivalents. It's the same exact thing as earlier. Same exact thing. And so what do we have? We've got ammonia, NH3. That ammonia is going to react with water. We are going to now create NH4 plus OH. Yay! Now, what do we have? What do we have? Plain and simple, molarity and volume. I got moles of NH3. 0.1 molar HCl. I'm adding moles of HCl to my moles of NH3. What do we know? If I have 10 NH3s, how many HCl's will it need? It is going to need 10 HCl's to send them all over here. We're going to add equal amounts of HCl to neutralize all of the NH3. And so what's going to happen now is I have my molarity and my volume. I now know my moles of NH3. I have my molarity of my HCl, and here's another way to look at it. I've got 0.01 molar HCl. I know how many moles of HCl I need to add. How do I know how many? Because it's the moles of NH3 I started with. And now I can find X liters of HCl I need to add to get them all in there. Once I have that, they all react. What am I left with? I am left with moles of NH4. Moles of NH4 positive. I now have the volume of the HCl plus the volume of NH3 I had. I've got liters of my solution. What can I do? I can now have the molarity of my NH4 positive. And you go, well, who cares? Well, this is a base, so that's a conjugate acid. So now what I can do is, I know NH4 positive is going to react as an acid would. It's going to create NH3 plus H positives. So what's going to happen? What's going to happen here? I had a KB for my last problem. If you look at the problems, I gave you a KB. I don't know if it's going to come in. It's right there. There's a KB right there for NH3. So now I can take that KB, divide it into KW. I now have the Ka for ammonium. Once I have the Ka for ammonium, I can now, Ka is equal to NH4 positive, NH3 times hydrogens, XX, 0, 0, XX. I have my amount here. Voila, I have my hydrogen ion concentration.